for this industry, definitely need the ideas. Those the company ever asked me to recommend some people. Okay. For this millimeter wave imaging, just now we mentioned parallel imaging of a high frequency. Okay. Currently in the airport, not every airport are using the so-called millimeter wave imaging system. Actually, in the United States, most airports actually have used the so-called millimeter wave imaging. Okay, right? But in Singapore airport, this has not been deployed. The idea is currently to detect the metal, still use the metal detector, right? Okay. X-ray now is used for the luggage. Okay, not for us. Okay, so minimum the plastic, for instance, plastic knife, very liquid, those explosive cannot be detected using the typical metal detector, right? However, the new technique, millimeter wave imaging or terahertz imaging, can be used for this purpose, for security application, right? Okay. If you are here, I just give you a concept. If you are interested, you can Google, okay, right? RFID. RFID actually there are many opportunities there. Okay. I guess Singapore. In Singapore, actually there are many different, maybe small size, big size RFID companies. Okay. Also, there are one big company from China set up the international headquarters in Singapore. Our friend is taking the director there. Right. Previously also hired the engineer. Okay. While we also hire engineers. Okay. RFID can have many applications. Then the recent very hot topic is wireless power, right? Wireless power. Okay, so this is a typical site. Okay. So wireless charging became very hot after this demo. This demo was made by MIT group in 2007. Okay, the idea is this primary coil, for instance, there are still two coils, right? Just now, I showed in our student project. Okay, in our student project, there are two coils. Also, in our EE4101E, we have learned the theory, right? We have learned the theory. One primary coil connected with power, right? Okay. Then another coil. Okay. This coil not connected with this primary coil, right? Okay. This line, okay, can be turned on. This called the wireless power, even with some obstacles. Okay, wireless power. So actually, the magnetic flux. Okay, we introduce the current. This magnetic flux, right? Magnetic flux. Okay. This is very famous demo. Okay. Published in Science. Okay. Published in Science. this we have learned in our EE4101E, the magnetic flux, okay, right? Also, wireless power was ever this top 10 technologies several years ago. But still, this technology is very hot. For instance, current product in the market is mobile phone can be charged, right? Okay, even the smart this can be laptop can be charged, mobile phone can be charged, smart furniture, okay, smart furniture. For electric car charge, okay, electric vehicle car, wireless charger, okay. Actually, I heard there is a research project in Europe. Build the project. What is the scope of that project? Is build the highway with the wireless charger coil for okay. Means neither embed the coil, embed the coil on the ground, okay? This is, for instance, primary coil. Then we need another coil underneath this car, at the bottom of the car, okay? The distance should be carefully designed. Also here needed the amplifier, okay? The DC cannot be transmitted wirelessly, okay? Cannot be transmitted wirelessly. Only the AC, okay? Only AC. Right? So previously, actually, in our EE4101E, I already mentioned, okay? For this, for wireless charge, I have also mentioned, I just now show the transmitter. Besides the coil design, also need to design the transmitter and the receiver. Right? Transmitter and the receiver, the idea is for the transmitter, need to generate the AC signal from DC. Okay? Oscillator design. Later on we will, in our module, we will explain the concept of the design by oscillator or oscillator. Okay? So at the receiver side, also we will explain the theory, how to design the receiver. Okay? Receiver. How to convert AC to DC. Okay? Initially is convert DC. And this end from the DC to AC. The AC can be transmitted wirelessly. Okay? So previously, for mobile applications, we are talking about wireless communication. Wireless communication transmit data, audio signal, right? Video signal. Now we are also talking about wireless power. Power also can be transmitted wirelessly. Okay? Means energy can be transmitted wirelessly. Right? Although you cannot see, cannot touch. Okay? Anyway, the energy of power can be transmitted wirelessly. Okay? Yeah, of course, for this kind of application, there are many challenges. Since especially for this kind of application, this transmitter power should be very high, not like the consumer electronic. Okay, maximum power level but quite low. For instance, to charge a mobile phone, right? To charge your fan. Just now I show you. Okay, all students ever work on IT. Okay, then for another industry also, the government has invested quite a lot for biomedical application or engineering. Oh, we are engineering, right? Engineering in medicine. Okay? So for the new new 5-year plan, okay? So called IE 2020, right? Okay? Maybe most of you or some of you have heard about this. Okay? Again, the government invests a lot in this. Of course, invest in the research. On the other hand, the government hope can generate more job opportunities. That is another punishment to evaluate how we are taxpayers, right? How taxpayers' money can be used to create job. Okay. So this is another potential opportunities. Okay. For biomedical application. For instance, wearable on-body medical communication. Nowadays, for instance, at the hospital, is a wired solution that will detect the body signal, right? Body signal, many wires are attached on the body. Not convenient. Nowadays, we are working. Actually, this is another ongoing project I'm working on. Okay? So to design this wireless sensor, like a plaster attached in the body. Then with a few sensors, the body signal can be detected. Okay, then transmit to the medical center, maybe through the computing cloud, since there are many patients. Okay, using the so-called big data, right? Okay. Through those gateway, so maybe this gateway, on body. Also, we are working on in body. Okay, in body is implantable. Okay, those electronic devices can be implanted into human body. Okay, right? Into human body to do what? Okay. Currently, there are 3 major areas. Actually, also my own research group also are working on these 3 areas. For us, I'm partially involved using our microwave antenna background to support this project. Of course, for all this is a huge team. We are collaborating with other colleagues. Yes, also medical doctors, other professors for working on the low power electronics. Okay, so what is neuro? Neuro is very hot topic. There are also opportunities for our health engineer. Okay, right? For instance, some area maybe could be hernia. Okay, right? Then how to control the limb movement. So need embed some electronics inside. Okay, detect the control signal, then transmit outside. Okay, since some electronics will be implanted in the brain. Okay, so how to power those electronics? So with the battery, then you have the patient have to do another operation, right? Okay, so that will introduce a lot of risk. Now engineers are working on the wireless power to power the implanted device wireless. Okay, wireless. Okay. So for those very advanced applications, you can do that. You have the knowledge, right? You have the knowledge. Okay? Very serious, you can do that, right? You have learned, you have the advantage, you have learned the electromagnetics, you have learned this eye communication, you have, later on you have learned the S parameters, right? Okay? Later also you will learn the ADS to design the IF circuit, okay? You can understand the IF language, Smith chart, okay? Smith chart. Compared with other students who have not chosen our IF communications modules, right? You have bad position, okay? For this retina implant, the idea is, so this is, let I give you a big view, how eye communications are very important, right? How eye communications are very important. Okay, retina implant, the idea is for those people who have the vision problem, okay, maybe blind people, right? Okay, the vision can be restored by using the engineering approach, okay? So for those, also IF technology play a very important role there, okay? For instance, this some device implanted inside the eye, how to power the implanted device, the wireless power. One coil outside, another coil inside, okay? Right? In addition to the coil, also need to design the transmitter receiver circuit, right? Okay? In addition to the power, also need to transmit the data. The antenna, right? The transmitter receiver circuit also will be involved. Okay? Then for the third area, so-called the peripheral nerve implant. For instance, currently we are also working on another big project. So the project, the idea is the nerve of maybe this arm could be broken, right? Then how to control the hand movement is a big challenge for medical area, okay? Medical area. So although in medical area can use some approach to extend the nerve, but not always successful. Currently, from an engineering point of view, we are using some approach. One is putting some sensor at this end to detect the control signal from the brain. At another end, we use some stimulator to stimulate the muscle movement. Okay? Right? So again, for this, neither some device implanted, some device outside. Okay, outside. Right. So then the wireless power and the data transmission wirelessly will be involved. So for myself, more are involved in those quite relevant to EM microwave, of course. Many doctors, how to understand the signal from the brain, the neural signal processing also is very important. How to translate those signals, okay? very recently also we are talking with another industry, hearing aid, right? Hearing problem, okay? This is previously German company, okay? German company, okay? Now this company has more than 500, 600 employees in Singapore. We are talking some collaboration with them. Yes. Those our areas also are relevant with them. Okay. They are also hiring new staff, working on antennas, RF engineers. Okay. Also need high engineers. RF energy harvesting. Okay. This is very important for Internet of Things. Okay, this is another smart nations, right? Okay, we are also very close to those very hot national project. Okay, for smart nations, IoT very important. There are many sensors. Okay, thousands sensors, maybe 10,000 sensors, changing battery, very tedious, right? If those sensors can be charged wirelessly, okay, then fantastic. Okay, so currently I have an ongoing project on this, more than $1 million. Also collaborating with another industry players, okay, funded by NIF, National Research Foundation. Yeah, although previously I have some other companies to support previously. I was another project on advanced by using the magnetic transistor. Okay. Previously is electronic. Now we are also looking at the magnetic, okay, base transistor. Okay. Some examples. The mobile phone, working mobile phone can charge this LED. Okay. So previously we have talked a lot on the, also can give you some tips, okay? How maybe many of you could switch to another industry after you complete your degree, right? Okay? Seek more opportunities. Still some opportunities. Okay? Now we still need to look at the details for our RF communications. Okay? Transmission line are the most fundamental portion. Okay? Who can give me those examples of the transmission line which have been used for our daily life? Right? Transmission line. Power line, right? Definitely is the transmission line. Okay? Any other transmission line? Coaxial cables, cable TV. Okay? Cable TV. Coaxial cables have been used for cable TV, right? Also, actually, you have used this. Nowadays, fiber to the home. Okay? Have you heard the name fiber to the home? Okay? So then you have enjoyed the fast speed of the internet. Okay? Right. Okay, optical fiber, actually coaxial cable, even the telephone wire is one kind of transmission line, right? Okay, so you are very familiar with the transmission line, right? You are very familiar with the transmission line, although you may not realize, right? You may not realize, okay? The power line, Singapore is 50 hertz, some countries 60 hertz also is used, the corresponding wavelength, okay? So here also, later also we will mention, notice the wavelengths, okay, and the frequency. So for our low frequency electronics, the frequency is very low, right? Very low, okay? The big difference of RF communications and typical what those in your mind for low frequency electronics, the low frequency is a big difference in the wavelengths. Okay? Wavelengths. In our EE4101E also I have mentioned the relative length is the physical length compared with this wavelength, right? Compared with this wavelength. We care more about the relative or the ratio of physical length. So for instance, later I will show you, right? This length is this physical length, okay? Is long or short, okay? Long or short, okay? When we say this, we must have a reference, otherwise your description is not accurate, okay? For instance, this length is nothing compared with this length, wavelength, right? Okay? Is very, very short. However, this length is very long. For instance, Wi-Fi frequency, gigahertz. Okay? Gigahertz. Right? So bear in mind, this is big difference of RF engineering and the low frequency. So those in your mind, okay? This is a big difference, okay? One wavelength compare one period, okay? One period. Then the signal in one period gives sine wave. Sine wave. So from here to here, this from here to here is one wavelength. Okay, 90 degrees. Then from 0 become peak, right? Okay. From positive to negative, then another 180 degrees is a phase delay. Okay, phase delay. For digital signal, 1 could become 0, 0 could become 1. Okay? So the phase, so the ratio can be translated to the phase, right? The ratio. Or electrical length. Physical length compared with the length is electrical length. So in our IF micro area, we call the electrical length. Is the physical length compared with the wavelength. Okay. Actually, electrical length can be translated to the phase delay. So for low frequency, because this electrical length is close to zero, right? This length compared with this, the ratio is close to zero. Then the delay is close to zero, right? Okay. However, for high frequency, for instance, 10 gigahertz, this nowadays, for instance, for computer, the frequency also is going up, right? Okay, going up. The wavelength, for instance, 10 gigahertz is for PCB, okay? Microchip lines. Microchip lines are very popular, okay? For mobile phone, the hardware, also microchip lines have been used, okay? Have been used. That's why the size can be made very small, very compact, because of this contribution. Okay? This contribution. For instance, this signal frequency, 10 gigahertz, their wavelength is 3 millimeter. 3 millimeter is very, very small, right? So then this length can cover a few wavelengths. Means, okay, small distance. Then the signal can from the peak to zero, maybe from zero to negative peak. Okay, negative peak. So means unpredictable. Okay, right? So because of this phase delay, the signal will be distorted, right? The digital signal also will be distorted. 1 could become 0, 0 could become 1, right? Okay? So coaxial cable, so you are very familiar with those coaxial cable. Also I bring the coaxial cable, like this one, right? Okay? Actually for high frequency, the coaxial cable is more expensive. Okay? Also we have some other coaxial cables. For high frequency, this is for low frequency, for instance, Wi-Fi 2 gigahertz, 1 gigahertz, 5 gigahertz, no problem. For